So let's start with the first presentation about the impact of wind on building air tightness tests. So, and here is a view of ventilation information papers that we have published in March on this subject. So this was an AIVC project. We have set up a working group to work on the impact of wind on air tightness tests with the objective to better understand the uncertainty due to wind on the result of air tightness test, and to provide a literature review on the subject, and to improve the air tightness test methods, including calculation for better reliability and feasibility. So in March 2021, we have released the ventilation information paper that is freely available on the AIVC website. What is important also to notice is that those kind of documents are peer-reviewed, so it's something that has been checked by a peer. Here is just, well, the list of the participants of the working group on this subject, so all those that have contributed on this research. And then I will go to the presentation of the VIP itself. So the first question was, why do we care about wind when we perform the air tightness test? So first of all, what is important to notice is that, at least in Europe, building air tightness tests have become more and more common in several countries, where a test is required with a target value to make sure that the low energy buildings are really low energy and are efficient. So it's necessary, as far as the test is required, to have reliable tests. And it's also necessary not to have too many limitations on allowable test conditions. If in some regions you cannot make you can only do the test 2 or 3 days in a year, then this is a problem. You need, as far as it's mandatory, to have not too much limitation on acceptable test condition. So sources of uncertainty in air tightness test are multiple. We have measurement device, of course, accuracy, precisions. Well, we can deal with it with the calibration of the equipment. We have calculation assumption with the regression analysis and the model itself. We have the tester behavior. So for that, we can do training, write about documents to explain how to perform the test, make competent tester schemes and things like that. And there is external conditions, wind and stack effect, on which we cannot do anything. And it's not really addressed in the ISO 9972. Also, regarding allowable test conditions, the zero flow pressure shall not exceed 5 pascals. This is the rules in ISO 9972 for the test to be valid. The problem is that some very windy regions, it can be very difficult to perform a test in accordance with the standards. And so while sometimes, well, the building is already so good that even if you have a big uncertainty, it's not that bad, because if you need to reach 0.6 and you have 0.2, even if you have 100% uncertainty, probably the building passes the requirements. So there is no need for this restriction. So what is the content of the ventilation information paper that you can download on the AIVC website? First, we have dealt with the physics. What is the reasons behind the problem of wind on air tightness test results? Then we have done a literature review on, well, every document, every publication dealing with this subject. So it can be an interesting starting point for researchers that want to start to work on this subject. And then in part 3, we have made a few proposals on how to limit the impact of wind on the result of the test. So first of all, the physics. What is very important to keep in mind is that the wind has an impact on the result of the air tightness test despite the zero flow pressure subtraction. So because in too many cases, people think that as far as we deduce the zero flow pressure measurements, then we remove the impact of wind. This is not true for 4 reasons. The first reasons, quite obvious, are the wind variations. You have no guarantee that the wind impact is necessarily the same before, after the measurements, and during the measurement. So you can have big difference during the 2 periods where you make the measurement and the zero flow pressure measurement, and when you make the actual measurement. The second reason that is often forgotten is about the external pressure gauge. So what the ISO 9972 say is that it's better to place the exterior pressure tape some distance away from the building, but not too close to other obstacles. The reason for that is if you place it behind a brush or something, in fact, you had an additional component in the delta P measured, which really depends on the wind speed here. So this is the second issue. The third issue is not wind variation, it's just wind fluctuations. So at a smaller scale, you can have very large gusts where you can see here on this measurement where we have the indoor pressure that varies of more than 20 Pascal within a few minutes here. So it's of course induced a large uncertainty, those wind fluctuations, those gusts. And then even in a perfect world where the wind would be perfectly steady and the external pressure gauge would be located perfectly at the right place, it still doesn't work because it does not work well because there is a model error. Because the flow rate through leakage according to the pressure is not linear, when you just subscribe the delta P0, you do an underestimation of leakage on the windward side when you are in pressurization and an overestimation on the leeward side, and all the opposite if you do the test in depressurization. So even in the perfect world, as the problem is not linear, this correction does not work properly and induce a model error. So those are the 4 issues of wind during pressurization tests, air tightness pressurization tests. So in the second part of the VI paper, we have tried to quantify this impact through the literature review. So there is 3 parts, in fact, in the literature review. The first part is about simulations. We have various publications on simulating the impact of steady and unsteady wind on the result of air tightness tests, mostly done by Rémi Carrier on this subject. There is still, and by Dimitris with the CFD tests, there is still a need to include also the stack effect to see the interaction with wind. There is still a need also to simulate multi-zone building and to do a better characterization of unsteady wind. And also with the characterization of unsteady wind, there is also a need for better knowledge of leakages behavior to know how they react to unsteady wind. In the literature review, we also speak about laboratory measurements because there has been the measurements performed in wind tunnels, like in our PhD by Adeline Melois, but also at Nottingham University by Xiaofeng Zhang. Well, again, here in laboratory measurement, what is needed is to better define how the wind should be modeled, so not only steady wind, of course, and how to model the environment around the building, around the small-scale building. And then in the literature review, we talk about on-site measurements. So multiple on-site measurements have been done, and other will be discussed just after me by Gary and Dimitris. Very interesting study, for example, is this one from Ian Walker in Berkeley, where they have tested 6 houses in 6,000 tests to find out what was the impact of wind, and they found out that below 3 meters per second is better to do, well, a multiple test, and that above 6 meters per second is better just to do 1 point at 50 Pascal and extrapolate. But there is still, even if multiple study has been done, there is still a need for more studies to draw general conclusion and also to control some parameters such as the leakage repartitions to make parametric studies. So there is other things in this ventilation information paper, but to make it short, I come directly to the main recommendations that are said in the document to minimize the impact of wind. So the first one is to improve the zero flow pressure measurements. The idea is to increase the duration and frequency of the measurement from 30 to 60 seconds make at least one data per second, and each data should be an average of at least 10 points. We also recommend to monitor the wind during the entire test to detect variations. Second part, very important, is to choose carefully the location of the pressure tapes, and mainly the external pressure tapes, and let the gauge exactly at the same location during the whole test. This is very important, and maybe to use T-pieces to put the pipe some distance away. Very important also is to stop making a basic linear regression and use a weighted method for the regressions. It's allowed to decrease uncertainty and also better estimate uncertainty, so that's very important. And adapt the pressure difference sequences. One very important thing is that when you average the result of the pressurization and depressurization test, you decrease the error, so this is very important. And you do also, if you want to estimate the pressure at 50 Pascal and it's very windy, then it's better just to do a single point test. You have no reason to do a regression. It's better to measure at around 50 Pascal. If you want to test at 4 Pascal with a wind of above 5 meters per second, then it's also better to just do a single point at 50 Pascal. If you are below that, then you can do the usual multi-pressure point measurement. And also carry out similar pressure measurements during the air tightness tests and during the zero flow pressure measurement with the same interval and the same duration. So this was my presentations. Thank you for your attention.